So now we're going to look at combining events, and this is going to be the probability of A and B when you're looking at combining independent events and you want both of them to happen at the same time. So this shorthand here, just so you see that, this upside down thing equals and in shorthand. So this here says the probability of A and B is equal to the probability of A times the probability of B. You could write that out for yourself if you want. The probability of A and B, for the first part, is equal to the probability of A times the probability of B. So if the events are independent and you find the probability of more than one happening at the same time, we can do that by multiplying their individual probabilities together. And so here we're looking for A and B to occur together, and so we would times it. But the catch here, which we'll cover again, is you have to assume the events are independent, and we'll go over again what that means later on. Okay. So the probability of rolling a 5 on a fair dice and flipping a head on a fair coin, well, you can assume those are independent because rolling the dice should have no effect on flipping a coin. So 5 on a fair die is 1 out of 6, and flipping a head is 1/2. So you should get 1/12 as your probability. You just times them together. The probability of flipping a coin and getting heads 5 times in a row. So here we've got 1/6 times 1/2 times 1/2 times 1/2 times 1/2 times 1/2, because I'm getting heads 5 times in a row. So that's going to be a really big number. And if you do this into your calculator, you should get 1/192, or 0. Where did it go? No, I don't have it as a decimal. That's right. Or you can get it as a decimal. But one thing to keep in mind, that heads 5 times in a row, you can think about that as the probability of getting heads in any one situation is 1/2. To have it happen 5 times, you would do 1/2 to the power of 5. So that's heads 5 times in a row. So for instance, if I wanted to do something like, what's the probability of getting a heart out of a deck of cards? With a randomly selected card twice, well, the probability of getting a heart, that's 1/4 of the deck. So 1/4 of 52 total in the deck is 13. So there's 13 hearts. So you've got 13 out of 52, or that's 1/4, because there's 4 suits: hearts, spades, diamonds, clubs. And that you want to do it twice in a row, if you put the card back, be 1/4 squared, or equal to 1/16. So you can square, or put it to the 5th, or put it to the 6th if you're getting the same exact thing multiple times in a row. So key takeaway here from the ands is that you want to make sure, only if they're independent, that you just times them together. So if you're looking for more than one thing, times them together. An OR situation, this is the case where you're dealing with basically, I want A or I want B, or I could have them both happen at the same time. I don't really care, and that's what's going on in this diagram. This is the A part over here, this is the B part over here, and this is, well, they both happen together, but it doesn't matter as long as at least one of them happens. And we have a formula for this, which you see there. The U here means OR in shorthand. So this means the probability of A or B is equal to the probability of A plus the probability of B. Take away the probability of A and B. So this is OR, and this is AND. So if we take a look at our question here, if the probability of A is 0.2, so that's probability of A is equal to 0.2, and the probability of B is equal to 0.35, what is the probability of A or B happening? So we'll use our formula. The probability of A or B happening is the probability of A, 0.2, plus the probability of B, 0.35, minus the probability of A and B. So how do we do this? I don't know the probability of A and B, so what I have to do here is assume A and B are independent. So the probability of A and B is equal to 0.2 times 0.35, because when things are independent, you can just multiply those probabilities together to get them. So we get 0.07. So we'd say minus 0.07. That's that and. So adding this up and taking off that 0.7, you get the probability of 0.48. So that's the probability of A or B happening. So again, you do have a formula for that, and if you don't know the and, you would have to assume that they're independent to solve for that. And again, if they're independent, you can just times them together to get the and. So if the probability of it being raining tomorrow is 0.75% and the probability of it being windy is 0.9%, what is the probability of it being rainy or windy? So again here, I haven't told you this, and it might not be true, but maybe in this situation it is true that it's independent. So if you're going to assume it, you have to write it. Assume it independent. So probability of it being rainy and windy is equal to 0.75 times 0.9. So we can say here 0.75 times 0.9 is equal to 0.675. Probability of rainy or windy is going to be equal to 0.75, the probability of it being rainy, plus 0.90 minus 0.675. And we get here the probability of 0.975. So with your or situations, you just want to remember there's that formula for it. And basically what it's doing is it's making sure that you don't double add that part in the middle. If you do have a diagram set up for this, you could just add the numbers. So if you remember that from level 2, if you have the numbers in the Venn diagram, you can just add them together as well. But with the distributions, we don't often have the Venn diagram, so thinking about that formula if you need it.